Welcome to our training on Fieldbus technology and integration solutions. A Fieldbus is a type of industrial digital communication network that links programmable logic controllers to data acquisition equipment, sensors, valves, switches, and actuators. ICP DAS USA provides programmable automation controllers, PLCs, HMIs, gateways, and converters. Many bring different protocols back to Modbus. We also provide repeaters, Ethernet switches, data acquisition, and wireless Fieldbus integration solutions. Protocols are used to send messages over the Fieldbus network. Some Fieldbuses used in manufacturing automation include BACnet, CANBus, CANopen, DeviceNet, DMP3, EtherCAT, Ethernet IP, HART, J1939, M-Bus, Modbus, PROFIBUS, and PROFINET. Fieldbus is usually networked together in daisy chain, star, ring, branch, and tree-type network topologies. Later in the training, Robert Murao, our senior application engineer, will be showing the setup and usage of our TGW-715 Modbus RTU to Modbus TCP gateway. If you have any questions, please enter them into the chat box, and we'll be addressing them at the end of the training. If you're working on any applications you want to go over, let us know, and you can also call us if you want to go over that. At the end of the training, we're going to be having a drawing for a $30 Starbucks gift card. I'm Maria Santella, our sales manager. I've been with ICP DAS USA for 11 years. Previously, I was application engineer, technical sales engineer, and web developer. We manufacture our products in Taiwan and ship orders out within 7 to 10 days. ICP DAS was established in 1993, and ICP DAS USA was launched in 2001. We offer ROHS compliant lead-free products, have our ISO 9001 certification, and our headquarters is in Houston, Texas. We provide industrial control products and data acquisition systems that are low DC voltage and operate in extreme temperatures between -13 degrees Fahrenheit to 167 degrees Fahrenheit, or -25 Celsius to 75 Celsius. We offer a knowledgeable team. We provide product specification, free technical support. We help answer questions, troubleshoot issues, and we can provide programming services if needed. Our products are very reliable. They come with a 1-year warranty, free easy data logger software that we provide for Windows-based data logging, control, and monitoring. It can be used with our data acquisition equipment, and as long as you have one of our Modbus devices in the network, you can use it with other vendors' Modbus devices. We also offer web-based and in-person training classes on PLC programming and SCADA programming. Gateways and converters offer data communication interoperability and network interconnection. They also allow for connecting and exchanging data with different automation devices as they facilitate communication between different networks or protocols. Most of our gateways convert Fieldbus communication back to Modbus RTU or Modbus TCP. Our gateways are easy to set up and use. Most are configurable over a web browser and no programming is required. We offer configuration services if you'd like us to set the IP address and other settings before we ship. In this diagram here, you can see at the top left, there's a PC that has our PCI cards that enable communication over CANBus. At the top right, you can see there's a SCADA system running on a notebook computer, which has communication to the CAN network through our I7565 USB to CAN converter. Our I7532 CAN bridge device connects a high-speed CAN network to a mid-speed CAN network. I7531 CAN repeaters help extend the communication distance and improve the signal. I7530 CAN to RS232 converters allow a PLC that controls a motor into the network. An I2534 CAN switch networks together different CAN networks that communicate over varying speeds. I7540D WF CAN to Wi-Fi gateways allow for wireless communication to CAN equipment. CAN remote I/O are connected to sensors and actuators. CAN communication cards in our programmable automation controllers allow for programs developed with VisualStudio.net and Linux to control and monitor CAN devices. BACnet stands for Building Automation and Control Network and is a communication protocol widely used in building automation and control systems. BACnet provides mechanisms for computerized building automation, devices to exchange information regardless of the service they perform. We provide BACnet network gateways that allow BACnet IP and BACnet MSTP devices to communicate with Modbus networks. GW-715 enables Modbus TCP client devices to access a BACnet MSTP network as a BACnet MSTP master. It's configurable as BACnet MSTP master or Modbus TCP server. It supports Modbus digital input, digital output, analog output, and analog input types. It supports the reading and writing to standard BACnet objects over Modbus. BACnet object properties mapping is configured via Modbus register. GW-2492M and GW-2493M bring BACnet client devices onto Modbus RTU networks. CANBus stands for Controller Area Network Bus and is a type of serial communication protocol commonly used in the automotive and industrial automation industries. It enables communication between different electronic devices, including sensors, controllers, and actuators. CANBus was developed by Robert Bosch in the 1980s as a way to reduce the amount of wiring and improve reliability in automotive systems. It's now widely used in other industries as well due to its robustness and high-speed communication capabilities. CANBus allows multiple electronic devices to communicate with each other over a single bus line, which is a two-wire network consisting of twisted pair of wires. Each device on the network is assigned a unique identifier, allowing it to send and receive messages on the bus. Messages can be prioritized based on their importance, and the protocol includes error detection and correction mechanisms to ensure reliable communication. CANBus is used in a wide range of applications, from simple systems with only a few devices to very complex systems with thousands of devices communicating with each other. CANBus has become an industry standard and is supported by many different manufacturers and vendors. We provide a wide selection of CANBus data communication and control equipment. We provide gateways that convert CANBus to Ethernet, fiber, RS-232, USB, Wi-Fi, Modbus RTU, and Modbus TCP. We also provide communication modules that can be added to our Linux-based LinPack programmable automation controllers and our Windows-based CE.NET WinPack programmable automation controllers. We have C language programmable controllers that communicate over CANBus. We also have CANopen remote I/O modules, J1939 to Modbus RTU and Modbus TCP gateways, and PC boards that add CAN communication. The ECAN240 is a Modbus TCP to 2-port CANBus gateway. It provides CAN communication over Ethernet and Modbus TCP for easy integration with SCADA and other systems. The ECAN240 has 2 CANBus interfaces and can act as a CAN bridge or a CAN message router. The CAN message router function allows for 2 to 4 different CAN networks, ensuring they can communicate with each other. The Modbus TCP server function implements communication between a CAN device and a Modbus TCP client. When the ECAN240 module is acting as a Modbus TCP server, the Modbus TCP client uses Modbus commands based on the CAN format. The ECAN240 translates the commands into the CAN format. When a CAN message is received from the CAN network, the ECAN240 translates the message into the Modbus format, which can then be accessed using a Modbus command. In Modbus TCP client mode, ECAN can access the Modbus TCP server via command configuration. When the ECAN240 receives I/O data, it forwards it to the remote CAN devices for analysis, control, or other operations. Once configured, the ECAN240 is able to access the Modbus TCP server via CAN message. In pair connection mode, CAN network 1 or 2 can communicate with network 3 or 4 using a pair connection configuration through the ECAN 240's gateways that are networked together with Ethernet cabling. In transparent mode, the TCP or UDP packet is in the CAN format and it contains the CAN ID. This is good for custom TCP UDP programs that directly access the ECAN 240 for specific applications. DeviceNet is a digital multi-drop Fieldbus network that provides connections between simple industrial devices like sensors and actuators and higher level devices like controllers. DeviceNet has a master slave and peer-to-peer capabilities. It's easy to set up and configure and supports up to 2,048 devices in a single network. We provide data acquisition, DeviceNet modules, gateways, PC communication boards, and communication modules that you can use in our LINPACK and WinPACK controllers. DeviceNet Gateways broker communication between DeviceNet protocol hardware and ICP DAS DCON or Modbus protocol hardware. DeviceNet supports both cyclic and acyclic messaging, which allows devices to communicate in real time and provides for more flexible communication options. DMP3 stands for Distributed Network Protocol 3 and is a set of communication protocols used between components in process automation systems. It's commonly used by utility companies, including electricity and water. It was developed for communications between various types of data acquisition and control equipment. It's primarily used for communicating between a master station and remote terminal units. Our DMP211 provides communication between up to 32 DMP devices and up to 16 Modbus TCP devices. DMP211 is a DMP3 master and can receive related DMP3 data. All the DMP3 IO data and Modbus address mapping is configured with our DMP211 utility. EtherCAT is a high-performance Ethernet-based Fieldbus system that makes internet technologies like HTTP, FTP, and web servers available at the IO level. With EtherCAT protocol, the controller can update the input or output when the data is needed. It supports daisy chain topology, which offers scalability and uses less wires, preventing interference and communication issues. An industrial communication protocol utilizing Ethernet technology, EtherCAT allows for high-speed, real-time communication in industrial automation systems. It allows for precise synchronization of devices and rapid data exchange, making it ideal for applications including robotics, motion control, and process automation. We provide EtherCAT remote I/O modules, junction switches, and EtherCAT to Modbus gateways. Our ECAT 2500 series EtherCAT junction slaves offer wiring flexibility and make it easier to set up and modify EtherCAT networks. EtherCAT junction slaves are not the same as standard Ethernet switches, as EtherCAT uses different communication methods than standard Ethernet, so junction slaves are specifically designed to work with EtherCAT devices. Ethernet IP is Ethernet Industrial Protocol and is one of the leading industrial protocols widely used in manufacturing and process control. It was developed in the 90s by a group in ControlNet International. The Ethernet IP application layer is based on the common industrial protocol that's used in DeviceNet and ControlNet. It uses all of the protocols of traditional Ethernet, including the TCP transport control protocol, IP, the Internet protocol, and media access and signaling technologies. Our GW-7472 and GW-7473 Ethernet IP gateways are useful in transferring data between Modbus RTU or Modbus TCP devices and Ethernet IP devices. Data is read between from the registers of Modbus RTU slave devices and Modbus TCP servers, and are fed into the input registers of Ethernet IP scanner devices. HART stands for Highway Addressable Remote Transducer and is a communication protocol used in the process automation industries. It allows two-way communication between smart field devices, and control systems. It's a hybrid analog digital communication protocol that uses a digital signal superimposed on an analog signal. HART sensors, valves, and other field instruments used in process control applications communicate over the same wires used for the analog signal, which means that existing wiring can be used. HART devices provide information including process variables, diagnostics, and configuration information to the control system. HART also allows for remote configuration and calibration of field devices, which reduces maintenance and downtime. Our HART to Modbus gateways allow for integration with a wider range of control systems. We have HART to Modbus RTU, Modbus TCP, PROFIBUS DP, RS-232, 485, and USB gateways and converters. We also have HART filters and analog input modules. J1939 is a communications protocol developed by the Society of Automotive Engineers for use in heavy-duty commercial vehicles and industrial applications. It's based on the CAN controller area network bus standard and specifies communication between electronic control units used in these applications. J1939 defines a way for ECUs to transmit information such as vehicle speed, engine temperature, and other critical information. It allows different components in the system to communicate and exchange information with each other, enabling better coordination and control of the overall system. J1939 specifies a set of message formats, data parameters, and diagnostic messages that can be used to facilitate communication between ECUs. The standardization allows different manufacturers to develop compatible components that work together seamlessly. We provide GW-7228 J1939 to Modbus RTU and GW-7238D J1939 to Modbus TCP server, Modbus RTU slave gateways. M-Bus or meter bus is available on a wide variety of heat, electric, gas, and water meters and has wireless capabilities. It's a European standard that was developed for reading and the networking of utility meters and heating systems. A 2-wire standard phone cable is the transmission medium for M-Bus. It supports 300 to 9600 bits per second communication speeds and up to 250 slave devices. The meters deliver the measurement data to a common master, which is sometimes a handheld computer, a remote computer, or a programmable automation controller. The master collects the data at periodic intervals to read all utility meters in the building. An alternative method of collecting data centrally is to transmit meter readings with a modem. We provide GW7828 M-Bus to Modbus gateways, I-7590 RS-232, 422, 485 to M-Bus converters, and coming soon are M-Bus repeaters. Modbus is a communication protocol developed in 1979 for the transmitting of data between devices over serial lines or Ethernet cabling. It's a master-slave protocol where a master device controls the transactions with slave devices that respond to requests or read or write data. It has built-in communication and control functions and supports multiple data types, including binary, floating point, and 16 and 32-bit integers. It provides a standardized way to access information from remote devices. Modbus is often used to connect PLCs or PCs running SCADA software to I/O and instrumentation equipment for automation, monitoring, and control applications. Modbus RTU is transmitted over serial lines like RS-232 or RS-485. Modbus TCP communicates over Ethernet cabling. Modbus RTU communicates up to 4,000 feet, and that distance can be extended with a repeater like our I-7510. Modbus RTU networks have one master and one or more slave or end devices, each with a unique address. Some applications use 2 or more integer registers for information like floating point data, where One register will hold the first part of the number, and the other will hold what's on the other side of the decimal point. It's up to the master, which is the controller or PC, to request and use the data. Modbus TCP encapsulates Modbus RTU request and response data packets in a TCP packet over Ethernet networks. Modbus TCP supports communication up to 328 feet, which can be extended with Ethernet switches like our MS205. Modbus TCP is popular and widely used in many industries, including building automation, energy management, HVAC, manufacturing, machinery, and cold storage. Our M-7000 Modbus RTU base data acquisition modules support Modbus RTU and baud rates from 1200 to 115,200 bits per second. They're configurable with the software utility we provide called DCON utility, which allows you to search the network, configure and test I/O modules. You select the COM port on your computer or controller that you're communicating over. You select baud rates, protocol, checksum, and parity bit when you search for your modules. You can use it to set input types like 4 to 20 milliamp current input, 0 to 10 volts input, or thermocouple input type. You can also use it to set the desired power on or safe value for digital outputs. Our M7000 modules support Modbus functions for reading coils, discrete inputs, and registers. They also support writing to the coils. If the function specified in the message is not supported, they provide error responses with error codes. They can be configured to have a power on and safe value, so when they're powered off, they'll go to that state. They have over voltage and ESD protection, 3000 VDC isolation, and a self-tuner inside. Their dual watchdogs have them reset themselves, ensuring they're reliable and stay up and running even if there's some communication issue or problem with the hardware or software. MBC 700 series Modbus data concentrators allow for reading and writing to and from Modbus RTU slaves from up to 8 Modbus TCP masters. They mirror the data of slave devices to its own shared memory, streamlining communication. We provide many controllers that communicate over Modbus, including our touchscreen PLCs that are programmable in ladder logic and C language. We provide demo programs for most common functions, including how to read data from Modbus devices and how to access their registers, how to make a touchpad a Modbus RTU slave device, how to make it a Modbus master, how to use the different widgets we provide, including counters, displaying temperature, reading data from a C language programmable controller, accessing I/O modules, lighting control, and more. PROFIBUS means process field bus, and it's a digital communication protocol used in industrial automation systems for connecting and communicating with sensors, actuators, and other field devices in the manufacturing process. It enables real-time communication between devices, provides improved control, monitoring, and diagnostic capabilities. PROFIBUS provides a high degree of flexibility and interoperability. It has a wide range of diagnostics and maintenance tools, which helps it for identifying and troubleshooting issues in systems quickly and efficiently. We provide a variety of PROFIBUS converters and gateways. PROFIBUS supports a maximum of 12 megabits per second speeds, allows multi-masters, supports up to 32 stations on one segment, supports up to 124 slaves and data exchange. Slave configurations and parameters are set with the master GSD file. Our Profi 5000 series are PROFIBUS remote I/O modules. Profi 8000 are data acquisition racks. Profi-2510, that's a PROFIBUS repeater. We also provide gateways including Modbus RTU, Modbus TCP, HART, RS-232, and fiber. PROFINET is an industrial communication standard built on top of Ethernet technology, so it has high-speed communication capabilities essential for real-time control and automation. One of the key benefits of PROFINET is its ability to integrate with existing field systems, including PROFIBUS DP, PROFIBUS PA, AS interface, Interbus, and DeviceNet. Upgrading communication systems to higher speed capabilities can be done without having to incur major changes to configurations and image structure. PROFINET offers real-time performance, deterministic behavior, and advanced diagnostics capabilities. It supports a wide range of industrial protocols, making it easy to connect different devices and systems together. We offer the PFN 2000 series PROFINET remote I/O modules, GW-7662 PROFINET to Modbus RTU gateways, GW-7663 PROFINET to Modbus TCP gateways, and the I-7580 PROFINET to RS-232, 422, 485 converters. ICP DAS USA provides total Fieldbus solutions, including PAC, programmable automation controllers, remote I/O data acquisition modules, and racks that communicate over a wide range of industrial protocols. We also provide PC communication and I/O boards, protocol gateways and converters, touchscreen controllers, IoT solutions, and wireless equipment. We also provide SCADA software. Prices for Aviva and IndySoft increase April 1st. So if you've been wanting to purchase a license, purchasing today or tomorrow would help you save on that. Now I'm going to be passing it over to Robert Murao for a demonstration of Fieldbus communication technology and integration solutions. He's going to be showing the setup and using the TGW-715, the Modbus RTU, the Modbus TCP gateway.
Use a Modbus TCP master to communicate to a Modbus TCP slave. Today I'm going to be using these three utilities / web browsers to do the demonstration. Our eSearch utility shown here is used to set the IP address of the TGW module. You must set it on the network. I'll go over some slides in a minute. Microsoft Edge is used to configure the TGW module, and we're going to finally use our Modbus Master Tool to show communication between our computer acting as a Modbus TCP master and a Modbus slave device. Let me show you a few quick slides. Let's see. Okay, so again, the TGW-715. In this configuration, we're going to use a Modbus TCP master, and we're going to communicate to a Modbus TCP, Modbus RTU slave device using the gateway feature. This module can also do the opposite configuration, but for this demonstration, we're only going to show the TCP to RTU, which is the more common feature. So in this example, normally, let's see, if the existing master is a Modbus RTU master and you have a USB to RS-485 converter, or your PLC is a Modbus RTU master, you just communicate directly to Modbus RTU slave devices using RS-485 traditionally, or occasionally RS-232. In this example, we're going to add our TGW-715 and convert the protocol from Modbus RTU from the slave devices over here to Modbus TCP protocol. Modbus TCP has quite a few additional benefits. Let's see, the benefits include the ability to use Ethernet connectivity. So if your facility already has an Ethernet infrastructure, it's very easy to add additional devices to the network. You can connect to remote devices through the internet. Say, for instance, you either have a different building, different facility remotely, like say a state away or something. But let's see, for now, let's see, you could also take advantage of Wi-Fi capabilities. So if your building has Wi-Fi capabilities and you use a repeater or a gateway to communicate to other devices, you can easily add this device to the existing infrastructure and use Wi-Fi capabilities to maybe communicate wirelessly to a device in the middle of the floor or something where it's very hard to add wires. And it also saves on wiring costs because Ethernet cables are much easier and much more easy to manage than RS-485 communication. The ability to ping a device is actually one of the main reasons why it's easy to troubleshoot if a device goes offline. Say, for instance, if RS-485 device goes offline, it could be something as simple as signal strength, or RS-485, the cable being broken or a wire being disconnected. You could more easily tell the difference. With Ethernet, you could also branch off more easily. RS-485, you traditionally have to go in a straight single bus line. So, for instance, it's more like a pipeline type architecture, and where you have to go in multi directions. You could use a RS-485 hub, but that adds additional flexibility, or I'm sorry, inflexibility, where it's harder to troubleshoot it as well. So if devices go offline, then what do you call it? You need to figure out what happened to the RS-485 bus, where the disconnection is. But Ethernet cables, you just pretty much click it in, verify communication by pinging the device, and you can more easily troubleshoot if a device goes offline. Then it could just be the Ethernet switch, or the slave device itself is not powered on, but you can tell more easily which device is offline. Again, I mentioned earlier, you can add devices more easily to the existing Ethernet structure by just plugging into an empty Ethernet port anywhere inside the network. The Modbus TCP benefits also include the ability to communicate from multiple master devices to a single or multiple RS-485 slave devices. Modbus RS-485, or Modbus RTU rather, usually you can only communicate from one master to a bunch of slave devices connected to the same RS-485 port. With Modbus TCP, you can add an HMI or a SCADA system to monitor the individual devices, as opposed to branch off from the PLC controller or the other, Modbus RTU master communication. So it makes communication setup more easily, and it saves processor speed on the main PLC. You don't need to monitor RS-485's signal strength or use repeaters or hubs to branch off in different directions, because, again, Ethernet is more flexible in its architecture and allows you to either branch off or, use an existing Ethernet network. And standard Ethernet devices like switches, hubs, routers, and so on and so forth. Let's see, for this example, our TGW-715, we're going to assign an IP address to our TGW module as a master device for the slave devices. We're going to connect to the web interface to configure the port settings for the RS-485 devices. We're going to set up communication parameters for the serial ports, including baud rate and parity options, to match our existing Modbus RTU devices, which were previously configured. And we're going to set up the module, our Modbus Master Tool, using or as a Modbus TCP master. There we go. Okay, and we're going to test communication to existing Modbus RTU slaves connected to the TGW's serial port. Okay, let's see, now I'm going to show the example. Oh, and for troubleshooting, let's see, again, you're able to ping the TGW to make sure it's still online. I'll show you the monitor tab in a minute, and we're going to use our Modbus Master Tool. You can also use the Modbus Master Tool in conjunction with your PLC or HMI to test communication. So it's actually a very nice tool. It's similar to ModPol, ModScan, but it's our free tool that we created, that we're able to use license free. And let's see, you can also check slave configurations and register tables to verify communication is set up correctly. Let's see, let me end this. Okay, so first we're going to use our eSearch utility. Oh, actually, you know what? Let me show you really quickly over here. What I have connected is our M7019R. This is a Modbus RTU slave device. Let's see, it's going to be set up so that we're going to pull analog input registers. I have a battery connected to one of the analog input, so I'll be able to show you a live value during this live demonstration. Okay, right here is the Modbus register table for the M7019R. To set up the communication in the Modbus Master, you need to know what registers you're pulling. In this case, I'm going to be pulling the analog input registers, of which I have a battery connected, a 9-volt battery connected to one of the inputs, so we can read a live value. And we're just going to monitor registers 30,001 to 30,008, which are channels 0 through 7 on the module. Okay, first we're going to use our eSearch utility to search for the module in the network. Let's see, once the module is found, we want to click on the line and assign the IP address. We use our eSearch utility for doing this. If you want, you can also set your computer on the default network, but this is the easy way to do it. So let's put 101. Let's see. You want to make this match your computer's gateway and subnet mask and have its own unique IP address. So it's not the same IP address as your computer, but it's set up on the network as a separate device. And let's see here. Once we set the IP address, we want to scan to make sure that it picked up the new IP address. Then we can either highlight here and click on web, or in this case, I'll just open up Microsoft Edge and type the IP address of the TGW that I just configured. 101. It should bring up the web interface. First thing you must do is assign a new password. Let's see, for the module, by default, it's admin, all lowercase, but I'm just going to use the letter A as a password for this example. Then it makes you log in one more time. I'm just going to submit that. Then the first thing you want to do is configure the port 1 configuration so that you can communicate to your Modbus RTU slave devices. So for instance, in this case, my baud rate is set for 115.200 to match the device previously configured, but you can set the baud rate and parity option shown here in the port 1 settings. Once you set that, you just click the submit button and it would save the port settings. And then this is the monitor tab that I mentioned earlier. Right now, there's no communication happening, but later on, I'll show you this screen and show you how to troubleshoot with this. Okay, so from here, let's use our Modbus Master Tool, set up a connection. What happened? Why did not open? Let me come over here to my file explorer and open it from there. Let's see, let me bring this over here. This is our Modbus Master Tool. Let's see. The first thing we must do is set our address range, which shown here. Come back here, and we modify our window here with the setup for the definition. So let's see. In this case, we're going to be monitoring input registers. So we want to go function code 1. Our slave ID for the module was 1. That was previously configured. The start address is 30,001, so it's a 0 offset. So this value stays at 0. We're going to do 8 registers. So we want to modify the length. And the value is going to be assigned 16-bit number. And we just click OK for that. If we had multiple slave devices, we can also add additional windows here by just clicking new windows and monitor slave ID 2, 3, 4. This is a great troubleshooting tool to verify communication through your TGW module. Okay, in this example, now we're just going to connect to the module. The TGW module is Modbus TCP. The IP address I set was, what did I set? Let me go back to my eSearch. 101, so 22.127.198, and I want to change this to 101. Devices connected to port 1 are going to be TCP port 502, which is pretty much a standard for Modbus TCP. And once we connect, we have no errors. We see no values here, but let me connect the battery that's connected, then we'll see some values live here. And I have it connected to channel or analog input 3, which shows up as in Modbus register 30,004. It looks like it's reading about 9.5 volts. The decimal point is not compensated for in Modbus, so the master must define or scale the number. In this case, 10 volts or plus or minus 10 volts with 3 decimal places. So what this is actually reading is 9.521 volts for the battery that's connected to, in this case, analog input 3, shown as Modbus register 30,004. Let's see, we also have the ability to communicate if you had a Modbus RTU master and a Modbus TCP slave device. Let's see, with this module, I won't show that example today, but I have been asked that a few times before with this module. So it is you're also able to do that. Set that up. We go down to here, and instead of application mode, we just set it for client. And then it allows you to put the IP address of the slave device, and the communication parameters up here would be for your Modbus RTU master device. If you have any questions, now would be the time to ask them. I'll be happy to answer any questions concerning the TGW solution or the Fieldbus solutions that Maria talked about earlier. The most important thing to remember for this presentation is that our Fieldbus devices help bridge the gap from, say, one manufacturer's protocol or one manufacturer's protocol to another protocol. Most of the time, it's Modbus TCP or Modbus RTU because those are the most common. We also have Ethernet IP solutions. So if you have Ethernet IP devices, we can help you bridge the communication gap between say an Allen Bradley PLC and a Modbus slave device that may be existing from a previous installation or installed on equipment previously. Does anyone have any questions? If you have any questions, you can type in the Q&A box, or you can raise your hand in the Zoom interface and we can unmute the mic and you can ask the questions live.
Robert, you could go ahead and randomly pull the name out of the drawing for the winner of the $30 Starbucks gift card.
Let's see. Well, I like the number 7. So who's the 7th attendee?
Okay. Salvador.
Okay, Salvador, you are the winner. Let's see. Any last minute questions? If you do have any questions that you'd like to either discuss offline or think about it afterwards, please feel free to contact us. And otherwise, we'll see you next time. And you have a great rest of your day and week.